Hello everyone, ZephyCloud is now released, and ZephyCloud is here to address three of the main frustrations of every Win engineer: long calculation time, lack of powerful computer hardware, and expensive licensing costs. To be fully transparent and in order to showcase the performance, we are going to run a live calculation on the Crea project in this video and control the time with a stopwatch. So first of all, to log in to my ZephyCloud account, I just put my username and my passwords, and the database will automatically recognize my accounts. So as we can see, I'm a gold user, so we have three types of user: bronze, silver, and gold, with different pricing and different levels of services. And I still have about 450 Zephy coins on my account. The inputs required by ZephyCloud are fairly standard inputs, so we need to input a orographical file, a roughness file, as well as mass coordinates, and if the microsighting has already been performed, you can also input all the turbine coordinates. So these coordinates can directly be copy-pasted from any other text file or CSV file. And once all these inputs are entered, so a topographical file as well as all the entities coordinates, the software will automatically propose one WRG area which covers all the different entities. And of course, if the user would like to have a larger WRG area, in that case it's of course possible. Then the height needs also to be entered. So here in that case, in the Crea site for instance, by inputting all the different coordinates, turbine coordinates as well as met mass coordinates, we can see that the resulting WRG size is of 2.8 by 2.8 kilometer. Once ZephyCloud knows the exact dimension of the WRG, the user still needs to input what required resolution he would like to use for this calculation. So basically, which has to do with the total number of cells. So it goes from 2 million cells per direction all the way till 20 million cells per direction. He also needs to input how many directions he would like to run. So from 8 direction all the way till 72 directions. He also needs to input how many iterations he would like the solver to perform for each direction. So from 750 iteration all the way till 2,500 iterations. We've decided to use 6.5 million cells per direction, which leads to 23.9 meter resolution, 36 directions, so basically a total of 234 million cells. The number of iterations has been set to 750, so this will cost us 51.9 Zephy coins, and we will get the results within 1 hour. Okay, the calculation has started, so I'm gonna just speed up the videos so that we get the results and see how long it took. As we can see, it took us about 3 minutes to define the entire project and to start the calculation via ZephyCloud. The configuration we're using to run this project is part of the 162 cloud configuration that we have designed that goes up to 72 simultaneous 36 core instances. All these configurations are unlimited in terms of number of users, and they are fully on demand without any upfront costs. After a bit more than an hour and a half, we get a mail notification that the project has been completed. So it took basically 1 hour to run the 36 directions and a bit less than half an hour to do all the pre-processing, including the meshing. Once the project is retrieved from the cloud, so we have access to the entire results, and we can perform all the visualizations as well as all the post-processing. So let's start with the meshing part. So as you know, in ZephyCFD, we're using unstructured meshing techniques as well as cylindrical calculation domain. So apart from the 6.5 million cells that was defined through ZephyCloud, we have also defined two other meshes, one with a bit less than 3 million cells and another one with 1.8 million cells, so that we can also compare different levels of refinement. So here we can see that we are looking at, for the three different meshes, we are looking at the ground discretization, the roughness discretization, for both the fine mesh as well as the coarse mesh. So every calculation is divided into one initialization calculation that is being done on a coarse mesh and one final calculation which is being done on a fine mesh. So we can also compare all the three meshes directly by generating a report. So in this report, the first table is a comparison table that shows exactly what are the different parameters of the three different meshes in terms of resolution, horizontal, vertical, in terms of smoothing and all the other parameters. All the visualizations, including both 2D ground visualization as well as 3D mesh visualization, are automatically integrated in the PDF report. Of course, all these PDF reports can be customized using users, organizations, logos, fonts, colors, etc., etc. We can also generate directly from the software HTML presentations that can easily be shared with your colleagues and partners. So all this information is also made available through this kind of presentation that also includes all the different 3D visualization as well as all the different videos that were generated with the software. So right now we were looking at the mesh we have generated directly through ZephyCloud, but we can also check out the other mesh with 3 million cells. Another important aspect of the mesh that we are generating with ZephyCFD is that the interest area is with the highest refinement, and we consider an area which is with a diameter which is 20 kilometer bigger in order to make sure that the flow is well initiated before it reaches the target area. Now let's see all the different calculations. So all the 36 directions. Here we can generate ISO height visualization. We can also look at the history of all the different simulations. We have visualization for the 4 main parameters, so the inflow angle, horizontal speed up, turbulence intensity, as well as flow horizontal deviation. So once all these visualization are generated, we can also generate reports for this step as well, where we have access to all the different parameters very transparently. We can also see the convergence, the stability of the results at the key locations, all the different visualizations that we have generated through the interface for all the different directions. And similarly, we can also ask the software to generate an HTML presentation. And here, similarly, you will have access to videos that combine all the different visualization for all the different directions, so that you can see how the flow is affected by the terrain for all the different parameters and for all the different directions very easily. Similarly with the profiles, we get this kind of visualization for the horizontal speed up profile, for the turbulence intensity as we saw before. You have also access to all this information direction by direction. So this was in order to compare all the different directions, but you get also all the different parameters direction wise. So now let's move to the next step, which is the rosing process, where we basically interpolate all the different CFD results. So here we have 10 degree by 10 degree directional results, which will eventually be made 1 degree by 1 degree result in the reference of the metmasts. Then the next step is the extrapolation, where we get to input all the different metmast data and extrapolate all this information to all the key locations and to the entire WRG area. And similarly, we have access to visualization, we have access to reports, etc., etc. As we've seen in this video, with ZephyCloud we managed to solve 3 of the biggest limitations of traditional CFD software. Of course, there are other problems, but we believe that these are crucial issues because it's not only reducing the added value of well-trained engineers who should not be wasting their time waiting for one result and hope that this is the correct result, because of course they don't have any more time to run the calculation again with a higher level of accuracy or with a different set of parameters. And we believe also that if we give wind engineers more analyzing time, less waiting time, along with the expertise for much faster, high quality results and much greater efficiency, we will manage to solve many problems in the wind industry. Cloud computing and open source software are actually changing the game because engineering is now limitless in terms of both accuracy and speed. You're welcome to try it for free and let us know what you think. Just go on our website, register, download the software and enjoy your first experience.